testing this because they want to show it on YouTube. Okay, it's recording. It's my first time doing this. So the plan of today's class is to introduce numpy and pandas to you, and these are the two links that are attached in homework 1. So we're hoping that you can go through the details of those two quick tutorials by yourself, but I will also quickly go through some basics of numpy and pandas with you in this class. To make it more interactive, I will use Jupyter Notebook and just quickly type something to show you how it works. I do expect you to install all the softwares by yourself and set up the environment. First of all, numpy is a library for scientific computing. I assume all of you must have heard of numpy. It's a library for you to do matrix computation and deal with n-dimensional arrays. So the basic unit of numpy is something called ND-array. Let me just make sure I'm really recording this. Okay, should be working. So to use numpy, you will need to import numpy as np. Then you can use np to access all those functions. Could you open the door for me? Then you can use np to access all the functions or the classes available from numpy. So to create an array, to create an ND array, you can use a plain Python list to initialize that. So what I can do is np.array, and I can pass a list 1, 2, 3, 4. Then assign it to a. Then it will give you an array. You can also pass a nested list, but this list has to be a rectangle. So I would do 5, 6, 7, 8. Then a will be of this shape. If you want to get the shape of the ND array, you can just do a.shape. It will tell you it's of shape 2 times 4. And you can also use some other initialization functions, such as, what else? Let me see. There are zeros. You could do numpy.zeros. Then it will give you a 2 by, let's say 2 by 4. It will give you a 2 by 4 matrix of ND array. And you can also do numpy.ones, 2 by 4. And don't forget there is a parenthesis here. If you remove that, it will give you an error because it takes a tuple of shape. So there should be an extra parenthesis here. And each ND array will have a type. So if you check the D type, it will have a certain D type. So this is an integer 64 bits data type. But you can also change it to any other type, such as float 32 or float 64. There, it is a double array. 32 is a single precision floating number array. What else? There are some other ways to initialize ND arrays, such as numpy random.rand. There are a lot of randoms. Okay, I believe this doesn't need a parenthesis. So there are some certain rules which is a little bit weird. Like in rand, you don't need to passing a parenthesis, but in other cases, you do need to do that. I know n means random. N means standard normal distribution, random initialized, and they are also random. Wait, so in this case, I believe you do need to pass a parenthesis. So there are some certain weird conventions here, and I don't think that's very important. So that's how you get an array. And you could also do numpy a range 10. This will give you an array from 1 to 10. And if you do 20, and then you can reshape an array to 4 times 5. That's how you reshape an array. As long as the total number of elements match, you can always reshape it to another shape. You can also reshape it to 2 times 2 times 5. And this will be a 3 dimensional 3D ND array. It has 3 dimensions. So that's the basics about ND array. You have shape, you have ways to initialize that. And now let's talk about indexing. Did I miss anything? Okay, we talked about these. Then the next is indexing. If you have an array, let's say I will rename it to B, and let's make it bigger. 100, 2 times. Let's make it 4 times 5 times 5. Then you got a pretty big ND array. And if I want to get access to certain dimensions, if I want to slice a certain dimension, then I can just pass in the indices, a range of indices. Let's say 1, 2, 3. Then it will give you row 1, 2, 2, and 1 is included, 3 is excluded. So it will be, if you check the shape, it will be 2 times 5 times 5. It will be 2 times 5 times 5. So this syntax is the same as a Python list. You can also do that to a Python list. Let's say if C is equal to a list of 1, 2, 3, 4, 5, you would be able to do 1, 2, 3. But if C is a 2-dimensional list, let's say if it has 2 dimensions, it's nested, then you would have to do it like this: 1, 2, 3. Let's say 1, 2, 3. Okay, this gives you nothing. Why that gives you nothing? 1, 2, 3. Okay, that doesn't work. So you can't get access to the second dimension. This will give you an error because you can't pass in a tuple here. But if you are dealing with a numpy and the array, sorry,
0 indexed or 1 indexed?
It's 0 indexed.
Okay, so that's
Yeah.
1, 3 gives you 1.
Right. 1, 3 gives you 1. Yes, you're right. But if you're working with a numpy and the array, then you can pass in the second dimension. You could do 1, 2, 3 again. Then this would, sorry, I should do 1, 2, 3. Then this would give you 2 times 2 times 5-dimensional array. And you can keep passing, let's say 1, 2, 4. Let's change to 0 to 3. And then it will be 2 times 2 times 3. So you will be slicing different dimensions altogether. It will give you a slice of matrix in a bigger a slice of the tensor in a bigger tensor. We usually call more than 2-dimensional matrix a tensor. So that's about indexing, and I think that's the most useful way to do it. Sometimes you want to do some kind of fancy indexing. For example, you could pass in 2 arrays of indices. You could do 1, 2, 3, and then 2, 3, 4. That will give you, let's see what that is doing. You can pass in again 0, 1, 2. This will give you 3 elements. So basically what it does is it gives you the elements of B 1, 2, 3. Let me write it this way. It's equivalent to 1, 2, 0 and B 2, 3, 1 and B 3, 4, 2. You will see the values are the same. So what it does is the first list specifies the indices of the first dimension, and the second list specifies the indices of the second dimension. So you're just gonna get 3 elements from there. That's I usually call it fancy indexing. Another useful feature is called Boolean indexing. So what that does is if you let me use a smaller array. So if you look at A, if you do A less than 5, this will give you a Boolean ND array with true and false values. But what's interesting is that you can use A less than 5 to index this array, and then this will give you 1, 2, 3, 4. And then you can change them to be 0. And if you do that, A will become this. So that's how you could select things based on some Boolean conditions and then change the values on those certain elements. That's Boolean indexing. Now let's go to some array math. I would like to talk about the following computations, because NumPy is designed for scientific computation, so that's the most important features of NumPy. So the first useful thing is element-wise computation. Let's say you have A, and let's make C to be equal to, let's make D to be equal to numpy.random.rand 2 to 4. Then D is an ND array with the same shape as A. Now if you do A plus B, it will do element, sorry, let's see what happens. It should be A plus D, right? Then you can, it will do element-wise addition. So you could check every single component. It should be element-wise addition. And similarly, you can do that for A multiplies D, and you can do A minus D, and you can do A, what else? A divided by D. And you could also do A to the power of D. That just means to the power of D, but you can also, there are some other ways to write it. You can do square. Is that square? I forgot. Or power. Maybe it's power. Okay, I forgot what the exact name is. But there are certain element-wise applications that you can find. So what's cool about NumPy is that you can do, what other function? You can do broadcasting with this kind of computations. What broadcast means is that if you do A plus 2, then it will plus 2 to every element of A. That's called broadcasting because you are broadcasting A to every single element of the ND array. And a more interesting application would be if you do A plus numpy once 4, it will also work. Let me give you another example. If you do A range 4, then what happens is that you have, do you realize what happens here? So A is this array, and numpy.A range 4 will be 1, 2, 3, 4. So what happens is that this 1, 2, 3, 4 one-dimensional array was broadcasted to every single second dimension of A, and then do element-wise addition. So the rule, there is a rule of the NumPy array. I wonder whether there is a good picture. I've seen a good picture explaining this idea of broadcasting. I just want to see whether they explain it well here. So the way it works is that, okay, so these are the rules. If the arrays do not have the same rank, prepend the shape of the lower rank array with 1s until both shapes have the same length. So what that means is that if you have two ND arrays and they are of different rank, in our case A is of rank 2, it's of rank 2, while this array only has rank 1, and it has shape, the shape of this array will be 4, and the shape of this array is 2 times 4. So what it does, if you're going to do broadcasting, then what it does is it will prepend the lower ranked one by 1. So it becomes shape 1, 1, 4. Now it will go to the next rule. If the two arrays are set to be compatible in a dimension, if they have the same size in the dimension, or if one of the array has size 1 in that dimension. What this sentence says is that to determine whether the two arrays are compatible in a certain dimension, they either have to have the same size or one of them has to be 1. So in our case, the second dimension, or I don't know, it's the first or second dimension, they are both of size 4, and the other dimension are of size 2 and 1. So they are both compatible because they are either equal or one of them is 1. And finally, the arrays can be broadcasted together if they are compatible in all dimensions. So 1, 2, 3 explains how broadcasting works. And after broadcasting, it's just element-wise computation. Okay, any questions about that? About broadcasting? It can be confusing if it's your first time seeing this. But let's do some more exercise. If I have a, let's make A to be, so there is an easy way to expand the rank of an array. So now A has shape 2 times 4, and if I do A none or none, let's see what happens. Now it has shape. It has shape 1, 2, 1, 4. If you specify a none in a certain dimension, it creates a new axis, but it doesn't have anything there. It's just a new axis without anything. But the shape changes. And now if you do, if I have another, let's say you have another array E, numpy A range 12 to reshape to 3 times 4. Now if I print E, you will find E has shape 3, 4. Actually, I want to remove one none here. Okay, now let's try. If you plus A to E, then you will see there the shapes are not compatible because one of them is 2 times 4, the other is 3 times 4, and 2 and 3 are not equal, and none of them is 1. So it doesn't work. But if you expand, if I expand it to, let's just do this. If I change this to none, will that work? Does that apply to the broadcasting rule?
Yeah, because it's going to put a one-dimensional extra on the E in
Yes.
the beginning, and so 1 and 2 will be compatible. 1 and 3 will be compatible.
Correct. So if you do that, you will get a. Let's check out the shape. The shape will just be 2 times 3 times 4, and the reason why it becomes 2 times 3 times 4 is explained by that student. It's 2, 1, 4, and it will be 1, 3, 4, and they will be broadcasted on the corresponding dimension. All right.
Can you print E and A just to see what it's doing?
Okay. E is this, and A. So, right, you can try to think about what it's doing here.
That just looks like A, right? The top thing is just A by itself.
So E would.
Oh, sorry, E by itself. Because you're adding zeros. I don't know why. I don't know what kind of math he's doing. But...
Right. So the first component is the same as E. So let's think about what it's doing. So A adding a new axis here would be of shape 2 times 1 times 4. And it will repeat 3 times in the middle dimension. So A will repeat 3 times in the middle dimension, and E will repeat twice in the first dimension, or the highest ranked one. So E will repeat twice, and it will both add A to it. That's what it does. But A will also repeat 3 times. You can spend some time thinking about that after the class, but that's basically what it does. That's about broadcasting. There are some other useful features about matrix multiplication or dot product. Let's see, I plan to talk about dot matrix multiplication, but before that, let's talk about sum. So if you have an array A, let's use E. if you do sum, it will sum up all the elements and give you a total. But you can also sum with a certain axis. If you specify axis equal to 0, then it will, let's see what it does. So E is of shape 3 times 4, and after the summation on axis 0, it becomes of shape 4. So what it does is it flattens the this dimension, the zeros dimension. And if you do E dot sum 1, so 1 just means axis equal to 1, then the 4 dimension is flattened and they are summed up. So if you check the results, let's print E again. You will find 12 is equal to 4 plus 8, and 15 is equal to the summation of those 3 numbers. So it's just column-wise or row-wise summation. And there are, this kind of programming also applies to max. You can do max over everything, and you can do max over certain axis, either 1 or 0, axis equal to 0. And there is also E dot min 0. There is also, what else? Mode?
Yeah.
What is?
We need that. We
Oh.
want the most popular, for example, of the parent.
I don't know whether it's. I don't think I've never seen this, so I doubt whether it has this. But maybe there's some other way to do it, but not here. So you can also write numpy sum E axis equal to 1, and that should be the same. What happens here? Axis, okay, axis. So that's the same thing, but with a different syntax. Then I plan to talk about dot and matrix multiplication. So dot it works like this. It's so we have A is of shape 2 times 4, and let's make another compatible shape. I'll do f equal to numpy dot random dot rand 4 times 3. Then if you do a dot f, it will give you an array of 2 times 3, because 2 times 4 times 4 times 3 will give you a shape of 2 times 3. So it's just matrix multiplication. And if you change that to a dot matrix multiplication, f, okay, so I guess you would have to say np matml a. That gives you the same results. The difference between these two operations are explained somewhere. I'll just show you the documentation. Dot and numpy mat. So the difference is, it's not very important, but if you're interested, you can read that. The difference is that if you have those two shapes, one of them regards it as a broadcasting rule, while the other thinks it's
It only does it if it's legal. You're saying, like, if the matrix multiplication.
if the dimensions are higher than 2, the behaviors will be different. But one of them thinks it's broadcasting, and the other thinks it's batch-wise multiplication. So you can take a look at the details later, but it's just a quick difference. But if you're only working with 2-dimensional matrices, then they are almost always the same. They are basically the same. What else? So one thing I want to say about this course is that whenever you're doing a homework assignment, if you find that you're writing double loops, if you're writing a loop inside a loop, you're writing nested loops, then it's very likely that you're doing it in a very inefficient way. Try to think about implementing it in NumPy, and this will be way more efficient. If you write a program and if you find it runs like more than an hour, then try to think about how to optimize that, how to use matrix multiplications instead of using loops. Because NumPy is very efficient and Python is a very slow programming language. So that will save you a lot of trouble. Okay. Now let's go to pandas. I'll quickly show you this website, but I do expect that you will read it by yourself as well. So pandas is another library about processing data, and pandas is based on it's built upon numpy, so it has a lot of similar features as numpy, and you can do almost everything in pandas if you can do it in numpy, but it also has some extra features that are very useful. So the basic units of pandas are series. A series is a single dimensional list. You can think about it as a 1D array. So in this case, if you pass in a list, you will get a series of these numbers with certain indices. The first column here are the index. Each of them is an index of the element. So you can use that to guess the element.
We have good class.
Okay.
Sorry.
Okay, sure. Is everyone leaving? So it will be just me. Okay.
I don't have class.
Okay. Okay. So we can sit closer. It's gonna be cool. Okay, so let's keep talking about series. It's like a one-dimensional array, but you have those different indices. In this case, though, all those indices are 0 to 5. They are numbers, so you can't tell any difference. It's just using 0 to 5 to use that. Actually, let me try to write that here to show you. So to use pandas, you will do import pandas as PD. Then let's just do let's just copy the code here and see what's happening. So S will be like this, and you can use S, the value of the index, to get access to every element. Yeah, like an array. Another object defined by pandas is data frame. A data frame is like a two-dimensional array. It's called a frame, so it's a two-dimensional thing. So you will, if you define it in this way, you will just get. Let's see, did I forget to copy something? Rand dates not defined. Okay, so dates has to be defined. Has to be copied from here. So in this case, they use some different index. So you will see df is like this. It has rows and columns, and the indices of the rows are called index, and the columns are called columns. So you have to specify both index and columns. And indices and index and columns are actually the same. They are both of type index. So if you check df index, it will be of some kind of index type, and if you check df columns, it's also of index type. So they're actually the same, and you can easily transpose it. If you transpose it, it's also a data frame. So now the original columns becomes the indices, and the indices are the columns now. And data frame, so these are the data frame. Let's see. Data frames have D types, and each column. So it seems to me that the in pandas they treat the columns as the major axis. If you print D types, it will show you the data type of each column, and each column is actually a series because it's a one-dimensional array. And if you want to view data, usually you can do df.head. It will give you the first few rows. And if you do tail, it will give you the last few rows.
You said it's series, but you can do multi-dimensional as well, right? Like you can put a. Can you have?
Do you mean
like grouping? I think you can have like grouping, and you can have like a value in the data frame can be like a table or something like that, right? So you can have like nested.
do you mean advanced indexing like what we had with numpy? Yes, sure, you can do that, and we will talk about that very soon. And if you just want the values from the data frame, you can do 2 numpy, then this will give you an ND array. So pandas is actually just a wrapper around a 2-dimensional array. It has those fancy index and columns, but everything inside there are just ND arrays. And describe is a way to describe, to give you some certain statistics of each column. You have the count, you have max, you have min. And you can sort values by an index. And selection, if you just just specify an index, it will assume you're trying to query a column, so it will give you a column. But if you want to get some rows, then what you do is you should do df.lock. Lock is a way to get some rows. So you see here, lock dates 0 will give you the first date, and A, B, C, D are the columns of that data frame that we've just seen before. I've just shown you before. Let me just print it again so you won't forget. So these are the numbers, and if you do df a, it will give you a column. But if you do df dates 0, it will give you an error because this thing doesn't exist in the columns. But if you do .log, then it knows that you're trying to query a row. Then it knows where it is. And you can also get all the, if you want to get all the, if you want to get more than one row, then you can actually do dates 0 to dates 3. It will give you a few more rows. So it's similar to what we have done to the numpy array. And the second component means how many columns you want, but you can also get just 3 columns. Okay, that doesn't work. So it seems like you have to do A to C, then you get from A to C, but they are all inclusive. If you do D, then it will give you all of them. If you do B, just get some of them. And if you just get a single column, then it will be a series. If you check the type of it, it's of type series. So it's of type series if you just get a single column. And if you just get a single row, it's also, so this is also this column is a series. This row, is this a column? Okay, this is also a column. But if you get a row, it should be also of type series. So that's about lock. And if you want to query by position instead of the name, the index, then you could use ilock. I should start from here. So df.ilock will give you the same kind of advanced indexing like numpy array. So you could do 1, 2, 3, 1, 2, 3, then you get something like that. All right, it's ilock. So Boolean indexing is the same as numpy. You can use that. You can use df.a to query certain rows, and then after you get rows, you can even change the values. Let's do the same here. df a equal to greater than something. It gives you some certain rows, and you can change that to be equal to 0. Let's see what happens. Now all those values should have been changed to 0, these rows. It also follows the broadcasting rule. That's why you can change all of them together. Let's see. So changing the values, I usually just do it use .lock. If you want to change some values of a certain row or certain column, I just query that and change the values. And if you want to create a new column, it's actually very simple. If you want to create a column E, and you want the values to be equal to A plus dfB, and you will find dfE just magically appears here, and the values are the addition of the 2 columns. And here's about missing data. If you see some of the values are of type NaN, which means not a number, and this drop NA is a method to help you drop that element. So from this example here, you see that drop NA always drops a row. So how equals to any means that if there is any NaN appearing in a single row, you just drop that. And one thing to be careful is that this df1.dropNA will create a new object. So df1 is not changed in place. df1 was still the old object, but it returns a new object. So if you want to change it in place, you have to assign it to df1 again. And fill NA is a method to fill not a number of values. So if you type fill NA, all these NaNs now become 5. And as is NA just returns true or false. If it's an NA value, then it will give you true, otherwise it's false. So these statistics are, you can compute the mean value. So this means mean by column, this means mean by row. 1 means the axis should be 1, so it's mean by 1. What else? Apply. I actually don't want to talk about apply, but apply basically applies to every single, I think it's applying every single row. So CumSum is cumulative sum. I forgot it's column-wise or row-wise, but you can figure that out whether it's column or row. Column-wise, okay. So it's accumulating, how that works. Let's see. Okay, anyway. And histogram is a way to, I think someone asked about how to group something together and accumulate. So that I believe this is how it works. So 4, it basically counts how many times 4 appears, and 4 appears 5 times, and 6 appears twice, and 2 appears twice, something like that. So another useful thing is merge. If you have 2 data frames and you want to merge them, then you will use you can use pandas concat, which means concatenation. This concatenation will help you concatenate either by columns or by rows. If you want to concatenate by rows, I believe you have to specify the axis to be equal to 1. Otherwise, it's just concatenating rows together by default, and the column numbers doesn't change. And join is a special way of concatenation, just like if you've learned SQL, if you're joining 2 tables, then you have to rely on some certain columns to join. So in this case, if you have left and right, these are 2 data frames, and they both have a key column, then you can say merge on key, and they will check whether key matches. So in this case, you have 2 keys of foo and 2 keys of foo. So you have 2 times 2. There will be 4 rows appearing in the merge table.
There may be some situation where you want to rename the column, right? So
yeah.
You do the join.
Yeah. So you can. This function merge provides a lot of other options. You can say left on and right on, and then you can merge on different columns, and you can also merge on index. It has I believe it has an option called left index, right index, which help you specify whether you're using the index. Let's check merge pandas quickly. I find pandas has a lot of options available. It has left on, right on, left index, right index. So you can do a lot of things with this function. And you can also specify the suffixes to, and the merged table will have a different column name. Let's see what else. Append. Append is just a special way of doing concatenation. It's like appending rows to another table. So now you can do df.append another series, and you can also you can append a row or append a column. It's a special way of saying concatenation. Grouping is the same as in SQL you have selected something from somewhere, group by, aggregate, something like that. Then pandas has the same feature where you can split a group into split a data frame into groups based on some certain criteria. For example, you can group it by certain column, and then you do some function to each group independently. Usually it's an aggregation function. For example, you want to group by column A, and then sum all the columns in a single group and then return it jointly. That's how it's used usually. For example, here, you see this data frame AB has A, B, C, D columns, and column A has full or bar. So if you do group by A and sum, then you will get 2 rows, full and bar, and the values are summed up in each single group. I don't want to talk about stacking. It's a way of turning index to multi-index. So indices could have multiple hierarchies, in this case, first and second hierarchy, and you can also you can turn them this way or the other. Yeah, I don't want to talk about that because I think it's not very useful. Pivot table, will skip that. Time series is a useful way of doing indexing because a lot of time you're dealing with a table with time series. Each single row is of a particular date, and then you can use time series. It's useful in some cases, but I will show you some examples later. I think that's almost it, and then you can it can plot some nice pictures, and you can read data from CSV or from some other formats. So that's a very quick introduction, and now let's quickly go through some of the examples I prepared. I have some data files in, let me list you, data. There are some files I downloaded from somewhere, and I want to read data from these files and show you how to work with them. So AAPL is a file containing a lot of stock data. So I'll do AAPL equal to pd.read CSV data apple.csv. Then if you check apple hat, you will find that these are the stock information of Apple, and the columns, these are the indices 0 to 4. But I want to make the date column to be our index because it makes sense to use a particular date as an index. So I could change read CSV to be pass dates equal to, sorry, I want to change index column to be equal to 0. So if you do that, now date becomes those dates. But if you check the type of the index, aapl.index, you'll find it's of type index. But in pandas, we have a special type called dates. So you could change pass dates to be date. You could also use 0, I believe, which means the zeros column. Then now you would see apple.index becomes datetime index. But you can also change the column index to be the name of the column. It will give you the same thing. And what's fun, what's useful about datetime index is that you can query year, and you can query certain year easily. Let's say if you want to query 2011.head, then you can just get all the dates of year 2011. It interprets those year and month very well. You can just query that easily. But without the datetime feature, you can't do it. It will just interpret as a plain string. And you can also plot them. So if you want to plot this stock, you can do matplotlib inline. It means you will plot everything in this notebook. Then I can do aapl.plot. It will plot all these numerical values. But the reason why this picture looks so ugly is because the volume is so huge, and it makes the other stock prices seems small. So you could just do ilog to only get the first 5 columns, I assume. 5 columns. Now this picture makes more sense. It's the stock trends of Apple. Let's practice something else. Now I have some other stock data. I have Microsoft and Google. Let's read that. Microsoft equal to pd.read CSV Microsoft and data Microsoft. And I want to use the same setting. I want to pass the dates and change the index. And I also want to read Google. So now I have 3 stocks. I believe that works. Microsoft is like this, and Google is like that. Now what I want to do is I want to concatenate those 3 stocks by column, so I can compare their stock trends. So the way you can do it is by, let's see how I should do it. You can concatenate by stocks equal to pd.concat, because that concat is a way to concatenate 3 stocks. Now, you know, all the indices are of date time, so they are compatible. You can concatenate them by the index. So now let's do Apple dot what should I do? Lock all. I should get a certain column. Let's just get, what column should I get? Let me get adjusted close. And I want to rename that. I want to rename the column from columns from adjusted close to Apple. Let's see whether this works. I want to first make sure this line of code is correct. So I will do it here. Okay, this works. Now you get the price of Apple, and you convert that to a data frame of only one column. And I want to concatenate with a few other stocks as well. So let's do that. And I want to change Microsoft, and I want to change Google. So this is Microsoft, and this is Google. Now you get all the stocks. Let's see what's the problem here. Okay, I guess that's just a warning, so that's fine. Let's ignore that, and you can dig into it later. And you see a lot of NANs. That's because I believe Google was not listed until a very late time. So you can change that to valid stocks equal to stocks dot index greater than or equal to stocks Google dot first valid index. So that will give you the first valid index of Google, where the values are not NAN. And if you see valid stocks, you will see, okay, what happens here? Stocks Google first valid index. I wonder why there are still a lot of NANs here. Okay, I see the problem. The reason is because when I concatenate them, I forgot to specify the axis. So I think axis should be equal to 1. Now that's right. Okay, now that looks right. Because if I don't specify axis equal to 1, it's concatenating by rows. It's just appending everything to the end. So it's not they are not columns. They are treated as rows. So now if I can plot valid stocks dot plot, that will give you a nice picture showing different stocks.
So axis equals to 0 as well.
I think so, yes. another example I want to show you is from another file. There's another file called movies metadata and ratings small. Movies metadata. Let me just do it here. So meta equal to pd.read CSV movies metadata. Let's see how it looks like. I forgot data. And meta.head. This is taking quite a long time because this file is big. So this file contains all of those metadata about movies. So this movie is Toy Story, and it has an overview and it has some other things. And I have another file called let's make it smaller. I'll just need 2 rows. And another file called ratingsmall.csv. It gives you all the movie ratings. And let's see what that looks like. Ratings equal to pd.read CSV data. Let's see ratings.head 2. It gives you such information. You have the ID of the movie, and you have the rating, and you also have a timestamp, and you know which user gives the rating. So now I want to do this simple thing. I want to analyze what is the average rating of a particular movie, and I want to rank them by the ratings. And you can do that with those with the information we have from those 2 files. So I will just do it. So first of all, this metadata has a lot of information, but I don't need so much of them. I only need the ID and I believe the movie title. So I will just so you can check that by meta.columns. It will give you all the columns information. So the useful information is, first of all, we want I believe there's a column called ID, and there should be another column called title. We just need those 2. The other things are not so useful for us. So we will do.
So that you can see what it is. You actually need the title for the drawing.
Yes, I don't need the title for the drawing. I just want to see what movie it is because the ID doesn't make much sense to me. Now let's do that. I will see what I should do. So I should be able to first let's get movie titles to be equal to meta.lock. I want to get all the rows, but I only need ID and title columns. And movie titles will be these movie titles. This looks good. And I also want to know the average rating of each single movie. That I can get from ratings.head. I should be able to do something about ratings.head and get the values, get the average ratings. So the way I'm going to do it is by the function we introduced called group by. Group by can group the values by a certain column. So I'll be grouping by movie ID, and I will do aggregation by. I need to do 2 kinds of aggregation. For the ratings, for the rating, I want to get the average rating. So I can pass numpy.min, and I also want to count how many ratings I received for each single movie. Because if it's only rated by 1 user, then maybe that's not very useful. If it's rated by 100 users, then the rating will be more representative. So I want to have the count of the ratings. So it doesn't matter which one you count. I could just count any single column. I could just count timestamp. Sorry, I want to do time. I want to do count, and then it should be about a certain column, and then I will do this count. I think that should work. Then you will get ratings equal to this. Let's see ratings. Okay, now you get all the ratings, and I want to rename some certain columns. So ratings equal to ratings. Yeah, I can ratings equal to ratings dot rename columns equal to timestamp to count. Now ratings becomes like this. So you have the rating and the count, and you have the movie ID. Now you can what's left is to merge this table with the movie title table. Okay, this is too long. I just want to show some certain rows. Okay, so now let's merge these two. How should we do that? So I can do I should do pd.merge. I can merge movie titles with ratings, and I should specify left on to be equal to ID, right? And right on to be equal to movie. I should specify right index to be true, because the movie ID is the index. So let's see whether that works. Okay, I'm typing it in the wrong place. I should type it here. So now you see some error, and I know what the error is. It says you're trying to merge on an object and int 64 columns. So I know the reason why this came up is because movie titles has something weird.
The types of indexes are different. The IDs are different.
It's actually not true. So if you check the error message, do that. If you check the error message, it says that you are trying to merge an object and int 64 columns. So what it says is ratings has the index of the ratings are of type int 64, but the type of movie titles are of type object. And let's further look into it. If you check the D type of movie titles, what's wrong with that? Data frame. Okay, D types. Then you will find they are of type object. They are not of type int 64. And pandas has a special function called pd.toNumeric. Let's see how it's used. pd.toNumeric. Then you can you should be able to change movie titles .lock or ID to numeric. Let's see whether you will find that it still gives you an error because it says it's unable to pass string this at position that. Then you can do that again to figure out what's this problem is about. If you try to find movie titles, some certain I think you can do .lock. What's that? Or
Isn't that a string?
all right. So let's see. If you do ilock 19730, you would realize that this row is of ID this weird thing and title of that. So that's because of the data set might have some problems, and you would have to clean up the data set. So I'm just going to clean it in a very stupid way, because you will find because there are not so many such garbage data. So I will just discard them if I find any. So the way I'm going to do it is by I will simply do a for loop for I in range movie titles dot shape 0. This is the number of movie titles. Then I will just try to convert movie titles dot lock I and ID. Actually, I should do so. That's fine. Else I not else, but if it gives you a value error, because if it's not an integer, it's some weird string, then you can't convert that to an integer, then you will get a value error. Then I will just change that value to be a very weird value. So I'm basically throwing that out because it won't be merged to any of the valid movie IDs. So let's just do that, and then I will convert that to be of type numeric. Okay, now I think it works. Now if you check the d types, you will find it is of shape int64. Now I should be able to merge. Now after I merge, I get what I want. It's, let me rename it, movie name ratings equal to that. Now let's see movie name dot ratings. And you may want to sort it by the ratings and also sort it by the count, so you can see what are the popular movies. So if you sort values by equal to rating, let's see what happens, .head, then you will see that's the highly, okay, I forgot to make ascending to be equal to false, so it's descending. Now you'll find that's those highly rated movies are, it just has one rating. So we could do by count. We could first sort by count, then sort by rating, and you will see this results will be more useful than those popular movies are ranked higher here.
Or you could filter by like a minimum count.
Yeah, you can just set a threshold there and get use Boolean indexing to select. Okay, I think that's all I have for today. Thank you for coming.